Alright, today we're going to continue using those basic rules of derivatives. In my first example, the only thing different I'm asking you to do is to find the equation of the tangent line instead of just finding the slope of the tangent line. So the way we're going to find the equation of the tangent line is by first finding its slope. But in order to find the slope, we're going to have to FOIL this out. So I get x cubed, I have plus x squared, plus 2x squared, plus 2x. I'll simplify this just a little bit further. X cubed plus 3x squared plus 2x. And then I'll take the derivative. And the derivative is 3x squared plus 6x plus 2. Now, I need to have the derivative at 1. So I'm going to plug 1 in for my x. And I'll solve. And I'll get that the derivative of 1 is 3 plus 6 plus 2, which is 11. So that's the slope of my tangent line to the curve. In order to have an equation of a tangent line to the curve, we need a point and a slope. We now have that. Here's my point, here's my slope. The point is y minus 6 equals 11 times x minus 1. In my second example, it's asking me to determine the point at which the graph of the function has a horizontal tangent line. So let me just draw some function here. Horizontal tangent lines mean that when you start drawing the tangent line to the curve, that the tangent line is horizontal. So it looks something like this. So that means that the derivative would be equal to 0 because the slope of that tangent line is 0. So what I'm really asking myself is, where does this function have a point where the slope of the tangent line is 0? So I'm going to find the derivative, which is how to find the slope of the tangent line. That would just be 2x. Now I really want to know, where is that derivative equal to 0? So I'm going to plug 0 in and solve, and I get x equals 0. Now every answer, when they ask you for points, needs an x, y coordinate. So you have your x coordinate. The way you get your y coordinate is by plugging back in for the original. So you have 0 plus 9, which is 0, 9. What I want to do is I want to take a second, though, and just sketch a picture of this graph. This is a parabola that goes through 0, 9. It has a vertex of 0, 9, and it looks like this. You can see from the picture, right there is the only spot where there would be a horizontal tangent line, which is the answer that we got solving it algebraically. In this next problem, it asks me to find k of this function such that the line is tangent to the graph of the function. So we want to figure out, where does this line pass through this function and be tangent? So let me give you a little picture. I know the square root of x, just if it said 1 square root of x, would look like this. And all that happens when you put a constant in front is it's going to lower it or raise it or make it skinnier or fatter based upon what k is equal to. What they want to know is, if I was to take this graph right here, or this line, what would I have to make k so that it would come up here and be tangent with y equals x plus 4? So I want to know, where is there a tangent line along the curve that has a slope of 1 so that these two will meet up with each other. So the first thing I'm going to do is rewrite this part so I can take the derivative of it, because I want to know, where is there a tangent line along this curve where it will match up with this line. So I need the derivative. That'd be 1/2 k x to the negative 1/2. So really, my derivative is equal to k over 2 square root of x. Now the derivative of this one, because, and the reason why I want to know this, is because I want these two to match up, so I need this tangent line to the curve to have the same slope. Well, this derivative is equal to 1. Now where are those two derivatives going to match up? At what k value? Well, really all I can say right now is that k is equal to 2 square root of x. That's not good enough. I want an actual number for k. So now I'm going to take this a little bit further, and I need to think about, all right, I have this function, y equals k square root of x. I now know that k is equal to 2 square root of x. All right, so I'm plugging in k is 2 square root of x, which gives me that y is equal to 2x. But it doesn't allow me to solve for x so I can see where these two will match up. So I need to use substitution where I take this y value and plug it in because I want to know where they match up, where they meet up. So I'm going to have x plus 4 equals 2x. Now when I subtract x, I get that x is 4. I'm almost done because that's going to allow me to solve for k finally. And I'm going to get that k is equal to 2 square root of 4. And the square root of 4 is 2, so 2 times 2 is 4. So the k value is 4. Alright, for this last problem in this section, what it's asking me to do is find an equation of the tangent line to the graph of the function f through the point x sub 0, y sub 0, not on the graph. So let me go ahead and talk about this a little bit before I even start doing the problem so that hopefully you understand more of what they're asking you. This is the function 2 over x. It looks something like this, and this is just a sketch. But what I'm showing you is that this graph is never going to pass through 5, 0. Here's 5, 0. It's never going to pass through there. Watch, when you plug in 5, you get 2/5. It's going to pass through the point 5, 2/5, but not 5, 0. So they want you to find a tangent line to the curve that will pass through a point that's not on the graph. So what we're searching for right here is we're searching for this xy coordinate where this tangent line meets up with this graph. So it says in order to find the point of tangency, this xy coordinate, we have to solve this equation. So what it looks like we need the derivative first. So I'm going to go ahead and take the derivative of this, but I'll rewrite it first. So this is 2x to the negative first. The derivative then is equal to negative 2, lower it by 1, x to the negative second. So I've got negative 2x over x squared. It's telling me to take that and set it equal to this other part. So what I'm going to do is I'm going to say, well, f prime of x is negative 2 over x squared. We're supposed to set this equal to y sub 0, which is 5. Nope, not 5, I'm sorry. Y sub 0 is 0. Minus, we're going to find this y coordinate, over x sub 0, which is 5. Minus, we're going to find the x. So when I cross multiply this to solve, because I'm going to get rid of my fractions, I end up getting negative 10 plus 2x equals negative x squared y. Now I can't exactly solve for x or y having two variables in there, so I need to replace y with something. Well, y is equal to 2 over x. So I'm going to plug in 2 over x for my y. So I have 2 over x here equals negative 10 plus 2x. Multiply these together, this cancels here, and so I end up getting negative 2x equals negative 10 plus 2x. And then I'll solve, and that gives me negative 10 equals negative 4x. And so x is equal to 10 over 4, which is 5/2. There's my x value for this point of tangency. So I'll go ahead and start to write that over here. My answer x comma y is 5/2 comma something for the y value. Again, you can find out what y is equal to by plugging it back into the original. The original up here, y equals 2 over, well, let's put in 5/2. 2 divided by 5/2 is actually equal to 4/5. So this is the xy point that we're talking about right here, it's 5/2 comma 4/5. So now I'm going to write the equation of that tangent line by using that point and this slope to figure out the answer. So the equation of the tangent line, I need a point and a slope. The point I figured out, the point is y minus 4/5 equals x minus 5/2. But I'm yet to find out what m is equal to. And the way I'm going to have to do that is by plugging in my 5/2 into my derivative. So I'll take this over here and plug in my 5/2, which is my x value squared. That gives me negative 2 divided by 25/4. And so when I divide negative 2 divided by 25/4, I get negative 8/25. So this would be the equation of that red line there.